Good evening, my sweet viewers. I hope you all are fine with the blessings of God. Now, in this lecture, I will be discussing about water transport system, and in this paragraph, इस पूरे paragraph में, the very first thing which I would ask you all, or I would explain you, that is what is translocation. What is translocation? आपको यहाँ पे क्या जानना है इस पूरे पैराग्राफ में कि ट्रांसलोकेशन क्या है, व्हाट इज ट्रांसलोकेशन. सो ट्रांसलोकेशन का मतलब है एक ऐसा टर्म जहाँ पर सब्सटेंस की मूवमेंट होती है एक रीजन से दूसरे रीजन में. मीन्स इट इज़ अ टर्म विच ब्रॉडली डिफाइंस द मूवमेंट ऑफ सब्सटेंस फ्रॉम एनी रीजन टू दी अदर रीजन. अब वो क्या हो सकता है, वो पैसिव भी हो सकता है, वो एक्टिव भी हो सकता है. किस पे डिपेंड करता है? एक्सपेंडिचर ऑफ द एनर्जी पे डिपेंड करता है कि वो एक्टिव होगा या पैसिव होगा. अगर एनर्जी की रिक्वायरमेंट होती है दैट मीन इट इज़ एक्टिव. अगर एनर्जी की रिक्वायरमेंट नहीं होती है इसका मतलब है ये पैसिव है. द मूवमेंट ऑफ वाटर अकर थ्रू द सेल टू सेल बाय टू प्रिंसिपल पाथवे. उसके बाद में हम डिस्कस करेंगे अबाउट द टू पाथवेज. विल डिस्कस अबाउट टू पाथवेज जिसके थ्रू क्या होता है, वाटर की मूवमेंट होती है. फर्स्ट वन इज सिम्प्लास्टिक पाथवे एंड द सेकेंड वन इज एपोप्लास्टिक पाथवे. So symplastic pathway means where water move from cell to cell via a plasmodesmata. And since cells are joined by the intercellular connection, the entire living portion of the plant form a continuous single entity and is called symplasm. So symplastic pathway means where the movement takes place through the plasmodesmata. And also here the term symplasm you have to remember here. A symplasm term, that term forms a continuous single entity. It is a living portion of the plant. The entire living portion of the plant forms a continuous single entity and that is called as symplasm. And opposite to that, a non-living portion of the plant is called apoplasm. And what is apoplastic pathway? It is another route of the route by which the water is get transported from cell to the other and by the intercellular spaces and non-living cells of the xylem. And in the symplastic, it get transferred from one cell to another by plasmodesmata. Also a term we saw here, that is symplasm, and it is made up from an entire from a living portion, where apoplasm term in the apoplastic pathway is formed from the non-living portion of the plant. Now we'll read about diffusion. You can smell from a distance the aroma of the food being cooked in the kitchen. A bottle of perfume opened in the corner can be smelled in another corner, and a crystal of the copper sulfate dissolved in the beaker of a water, turning the latter blue. So, does a drop of blue ink dropped in water? All the above phenomena highlights the common point, that is, the random movement of particle is caused by the inherent kinetic energy they possess. That means it is all meant to discuss about only one thing, and that thing is a phenomena which help in the random movement of the particle. That means it means to say that diffusion is that phenomena where random movement of particle takes place. Means ये बोलना चाहता है कि diffusion एक ऐसा phenomena है जहाँ पर random movement होता है particles का. फिर बहुत से examples दिए गए हैं. A lot of examples has been given. The first example is when the cook is food and we get smell even if we are not in the kitchen, right? Even if we are not in the kitchen, we are in our study room, in our bedroom, we get the smell of our food which is being cooked in the kitchen. Second one is perfumed. The perfume bottle, if you will open it in the bedroom, it might we get the smell in the sitting room, in the drawing room, also in the balcony. So all these are the examples which reflects diffusion. The particle strikes on another repeatedly, thus resulting in their dispersal in the different directions. Also, these particles would always try to move in a perpetual move in a direction where there is a minimum obstruction offered by the other particle. It would mean, therefore, the net movement would be favored from the area of a higher concentration to that of the lower concentration. You have to remember very, very important point, the last point, that diffusion occur and the movement of the particle which takes place in the diffusion are always from the higher concentration to that of the lower concentration. They are from the higher concentration to the lower concentration. Now, a region of a free energy to the region of the lower energy. Thus, the spontaneous process or the tendency of the particle, ions, atoms, or molecules of gas, liquid, or solid get evenly distributed through the available space due to the random kinetic motion is called as diffusion. In Latin, the meaning of diffusion in Latin means spread out. In other words, diffusion is a spontaneous process that leads to the directed net movement of the substance from the region of a higher concentration to that of the lower concentration, or simply as a net movement of the molecule from the region of a higher free energy to the region of a lower free energy. The term was coined by R. Brown in 1928. So the important line of this paragraph is scientist name according to their date, and then definition of diffusion, and then its few examples. Also its movement concentration according to the concentration gradient, that is from the higher concentration to the lower concentration. Also we can call it as from the higher energy level to that of the lower energy, higher free energy level to that of the lower free energy. And you will also remember its example also. You will remember its example also. And this date also, 1928. After some times, the particle molecules will evenly spread throughout the available space, and it would mean an equilibrium with the movement of the particles will be equal in all directions. The net movement will be zero. The process of diffusion can be explained based on the Fick's first law, a quantitative description on the process formulated by the Adolf Fick in 1855, which in its oversimplified way suggested that the rate of diffusion is directly proportional to the cross-section area of the diffusion pathway and to the concentration vapor pressure gradient. At the same time, the rate of diffusion is inversely proportional to the length of the diffusion pathway. So here some mathematical terms, directly proportional or inversely proportional term, has been explained by some scientists. And what it explains us that the diffusion is inversely proportional to the diffusion rate, and here this I'm literally sorry students, here not diffusion, this capital D is for diffusion rate, and this small d is for the density of diffusate, and they are inversely proportional to each other. Okay, just above this you can see the rate of diffusion depends on the several factors. It depends on the several factors: temperature, density of diffusate, and so on. So in case of a temperature, what happens? It is directly proportional to the temperature. As it increases the kinetic energy of the diffused particles. Diffusion, so a Q10 that denotes the temperature coefficient, and which it measured the rate of the change in any biological or chemical system because of the increasing of the temperature by 10 degrees centigrade. So here only important point is that it's the relation with temperature, which is directly proportional, you have to remember, and nothing else. Again, in second case also, this relation and nothing else. Thus the gas diffuses more readily than do not liquid, while the solid diffuses the slowest. Why? Because the density of the diffuser is inversely proportional to the diffusion rate. Now the third one is the pressure exerted due to the tendency of the diffusion to diffuse is called as a diffusion pressure, and because of the inherent kinetic energy, the movement of the molecule will take place from the region of the higher diffusion pressure to the region of the lower diffusion pressure. So प्रेशर ग्रेडियंट के अकॉर्डिंग मूवमेंट होगा, मीन्स हायर से लोअर यहाँ पे मूवमेंट हो रहा है. एट द सेम टाइम आपको याद रखना है द डेफिनेशन ऑफ द डिफ्यूजन प्रेशर इन दिस पैराग्राफ. Now the last one, the density and the concentration of the diffuser also influences the rate of the diffusion, and more concentration and dense the diffuser, lesser slower will be the rate of the diffusion. Here इसका मतलब हमें पता चलता है इनवर्स रिलेशनशिप है. डेंसिटी एंड कंसंट्रेशन ऑफ द डिफ्यूजन जो है क्या बोल रहा है कि कंसंट्रेशन अगर मोर होगा एंड डेंस होगा तो डिफ्यूजर का तो रेट ऑफ डिफ्यूजन जो है वो उतना ही स्लोअर उतना ही लेस होगा. इसका मतलब क्या है कि इनवर्स रिलेशनशिप है, इनवर्स रिलेशनशिप. उसके बाद में कुछ इंपॉर्टेंट पॉइंट्स है डिफ्यूजन के. द प्रिंसिपल ऑफ द डिफ्यूजन इज अ ग्रेट इंपॉर्टेंस इन द प्लांट. In the plant, as it is involved in the movement of almost all substances. Now, the processes such as the uptake of the water, minerals, osmosis, transpiration, exchange of the gases during the photosynthesis, and the respiration, short distance translocation in the symplast, spreading of the other substances through the protoplast, and weighting of the cell wall, are released of order for pollination depends on the part of the diffusion. So, here are some important points of diffusion, that why it is important. So, a lot of example has been given, like osmosis, transpiration, exchange of gases during photosynthesis, respiration, short distance translocation in a symplast, and many more. Now we will read about a term, that is imbibition. In Latin, imbiber means to drink, and it is a process that involves the absorption of a water or any liquid by a solid particle of an absorbent substance without forming any solution, and the liquid of the water which is imbibed is called an imbibant, and while the insoluble substances that imbibes water substances is now the imbiber are usually in form of colloidal particles and which hold the liquid water absorption, which holds the liquid water absorbed in the surface as well as the inside the minute spaces between the particle in themselves. Although the liquid involved in the imbibition in the plant of the water and the other substances may also act as an imbibant. For example, the rubber imbibes ether, kerosene oil rather than water. Most important among the plant imbibant are the hydrophilic colloids like the protein, pectin, starch, and cellulose, and these substances differ in their imbibition capacity. The phycocolloids agar-agar has the maximum imbibition capacity and can imbibe almost 99 times its weight of water. Now, protein also have high imbibition capacity of imbibing nearly 15 times water their own volume. Cellulose and starch are poor imbibant, and the lignin does not imbibe water. So, here are some examples which you must remember. Also, keep it in your mind, this sequence and the definition of imbibition. This is also a good example. The wood swells up and crack the rock. Now, factors which influences the imbibition. Rise in the temperature enhances the rate of imbibition. So, the very first temperature, it will enhance. Second one is texture of the imbibant. Cohesion of the molecule is inversely proportional to the imbibition capacity. So, gelatin with loosely packed particle will imbibe much more than hardwood. And the third one is about pH. Since the imbibant are predominantly colloidal, imbibition is influenced directly by the pH of the medium. As temperature enhances it, pH also influences it. pH is also play a role to influence imbibition. For example, negative charge colloidal like cellulose will imbibe maximum at the alkaline pH. Since protein are amphoteric in nature, their absorption is maximum or other alkaline or acidic medium, but less in the neutral medium. So you have to remember, as protein are amphoteric in nature, that means they will behave both as an acid as well as an base. That kind of things are considered as an amphoteric. So they will show maximum absorption, while that of alkaline or acidic medium will show, while that another alkaline or acidic medium. But in case of a neutral medium, it will be list, means absorption will be list. Also, you have to remember the second point about the texture of ambivent. And that's all for this video. We'll discuss the next topic in the next video. Thank you everyone, and if you like the video, then please don't forget to subscribe my channel if you are watching this video for the first time.